Uh, so it's my pleasure here to introduce GarrettFlores. Garrett is been with us about 2 years. Master's student, came to us from a school west of here. Plant biology major. So turfgrass was really a new thing for Garrett. I know that in his time here, I think he really developed an appreciation for kind of the applied side of plant and soils, and taking it really on to an application in ways to help people. So really been a privilege to have him as a student. He's going to try to finish before May, is my understanding. So, and he's going to share with you today about some of the research that he's been involved with using spent coffee grounds. So take it away, Garrett.
Thank you, Dr. Willie. Can everybody hear me? Good? All right, great. So again, my name is GarrettFlores, and I am here to talk to you all about spent coffee grounds today. So before we get into any of the data, I'd just like to have a quick discussion on why should you care? Why coffee grounds? Why turfgrass? You know, why does it matter? I just like to preface this with, like, I don't think that my research is going to win me any awards, but it's been very interesting and fun to work on, and I hope you find it as interesting as I have so far. Click on the screen. Okay. Okay, turfgrass. So why turfgrass? Why is that important? So I have read an article by Christina Malesi, and she estimated that there's approximately 164,000 square kilometers of turfgrass in the continental United States. And so that's everything from golf courses to sports fields to home lawns, parks, etc. So there's a lot of turfgrass out there, and that takes a lot of resources and time to maintain. So focusing on golf courses specifically, there's approximately just under 17,000 golf courses in the US alone. And it was estimated last year that the world's golf courses take about 9.5 billion liters of water every day to be maintained. And so even if we make a 1% difference on that, that's saving 95 million liters of water every day. So the turfgrass industry as a whole uses a lot of inputs, whether that be water, chemical, fertilizers, pesticides, what have you. And we need to start moving towards a more sustainable method of maintaining our turf, whether that be reducing inputs and saving water, and moving to more eco-friendly systems. And that's where we think coffee can help out. So why coffee? So just a quick show of hands, who here has had a cup of coffee today? How about 2 cups of coffee today? Okay, so I don't think I need to put any figures up to convince you that coffee is a very popular beverage, and it's only increasing in popularity all the time. With that increase in popularity, we have new methods of brewing, one of those being cold brew. So we are working with a cold brew coffee company in San Antonio called Aspen Beverage. And Aspen Beverage, at their current production rate, is producing 80 cubic yards of spent coffee grounds every day. And they're right in the middle of an expansion project. And by the time that's finished up, they plan on producing 160 cubic yards of spent coffee grounds every day. That's a lot of coffee grounds, and we are looking at agronomic aspects instead of just contributing to the waste stream. How can we use these spent coffee grounds in an agronomic way? So before cold brew coffee, there's never really been a centralized source of spent coffee grounds. You would have had to go to every Starbucks around the city in order to get enough to put in your garden, you know? So now we do have a commercialized, centralized source, and we can start using this in commercial applications. So I'm sure everybody here has heard of your grandma saying, you know, throw coffee grounds out in your garden or on your roses and they'll grow like gangbusters. Well, we kind of took that a step further and did a chemical analysis. And what we saw, besides a slightly acidic pH of 5.6, is we saw the NPK of 2.3, 0.1, and 0.5 respectively, as well as a carbon-nitrogen ratio of 20:1. And so this is the premise of us using this as our top dressing fertilizer study. So before we get into any of the data, I'd like to talk about some of the data that we collected beforehand, one of which being our turf quality. So the turf quality is a visual rating from 1 to 9, with 5 being the least minimum level of acceptability. We also looked at the normalized difference vegetation index, or NDVI, and this is the difference between visible and near infrared reflectance of vegetation cover. It is essentially the measure of photosynthetic efficiency of a given area. We also took lightbox images. So these lightbox images were analyzed under Sigma Scan Pro, and we analyzed both percent green cover as well as dark green color index, or DGCI. So our percent green cover is the amount of green pixels within the entire pixels of the image, and the dark green color index looks specifically at those dark green, or those green pixels, and determines how dark green they are. So it's more of a qualitative rather than quantitative measurement. And finally, we have our volumetric water content, which is simply the ratio of water volume to the volume of soil. And this picture, you can see me doing the clipping study of our soil amendment project. So this is how I collected our clippings. That's not the right button. So here, collecting clippings for the soil amendment study, which was giving them a haircut once a week for 6 weeks, which was not a whole lot of fun, but it was definitely much better than the clipping study for the field study, where I had to put a paint strainer bag on the back of our push mower, and paint strainer bags don't really collect all the dust, so a lot of that went straight to the eyeballs, and it was not a lot of fun. All right, moving on, fertilizer study. So this was my 2-year study. We did this on a Celebration Bermuda plot. This, we had 10 different treatments, one of them being a control, 9 different fertilizers. We applied these fertilizers 4 times a year at 2 different rates, one of them being a ½ pound nitrogen per 1,000 square feet, and the other 1 pound nitrogen per 1,000 square feet. And then in between all of this, we also did a 6-week clipping study on all of our plots, and we'll get into that a little more. Here's the field study ANOVA. I know we're supposed to keep the charts to a minimum, so I'm only going to be talking about our turf quality, treatment main effects, as well as our clipping mass treatment by date effects. So first of all, we have our mean turf quality, and we're going to run through these fertilizers really quickly. Untreated is obviously untreated. We've got our fresh spent coffee grounds here. And what this is we dried these down as soon as we received them so that no further degradation would take place. We've got our composted grounds here. The composted grounds were left outside for 4 months, turned once a week. We actually haven't found the endpoint of composted coffee grounds yet. We still have some out there that are over a year old, and they're still maintaining 60 degrees Celsius, so they're still cooking. We also have our GeoJava 421, and what this is 25% coffee grounds, 75% chicken litter. We have our Sigma 422, which is essentially just chicken litter, and our synthetic ammonium sulfate. So looking at this data, we can see that, again, 5 is our minimum level of acceptability, but we never let it get that far. Our untreated is not any different than either of our coffee ground treatments. Our GeoJava and our Sigma 422, both are better than all the rest of the treatments. So what we're seeing here is that if you extend these dates out a little further, the Sigma 422 does kind of scale back, and the GeoJava stays a little higher turf quality, but we'll get into that a little bit in just one moment. Basically, we're seeing the GeoJava act as a slow-release nitrogen fertilizer as well as the chicken litter. And what we're seeing is when we add only 4 applications a year, the quick release really drive back down to control levels very quickly. And so it dilutes out any of the positive results that we see, like ammonium sulfate. You get a very rapid green up, very rapid growth, but after about 6 to 8 weeks, you have control levels of turf quality, growth rates, what have you. All right, this one's a little more complex, so bear with me here as we get through this. This is going to be our clipping study that you saw earlier. We're going to go through this one by one, starting with our untreated. Stays about 20 grams per plot of clippings. Let's start with our fresh coffee grounds. So our fresh grounds here, you see a pretty rapid spike in the first week, and then it quickly drops back down to control levels of growth after week 2. And you see the same thing with our composted grounds in this blue line here. So whatever nutrients that they are providing, it only is a very short burst, and then it goes back to control levels. You don't really see this in turf quality, but you do see this in the clipping yields. So GeoJava, so this is again our coffee chicken litter combination. What we're seeing here is that it's acting as a slow release nitrogen fertilizer, taking about 2 weeks before it gets any significant levels of growth. One interesting thing that we did see here is that while the growth rates are pretty rapid and then decline relatively quickly, the turf quality stays higher. So you are losing some of these growth rates, which isn't necessarily a bad thing, especially in things like golf courses and sports fields. But you retain your dark green color and turf quality. So you may not have to mow as much while maintaining high quality turf. Our Sigma 422, you're seeing here in this brown line, you don't get significant spikes in your growth rates, but you again do maintain high levels of turf quality as compared to our ammonium sulfate, this black line on the top. What we're seeing here is rapid spikes in growth, but the turf quality also spikes with this, and as it drops down, so does your turf quality. So that was one of the interesting things we found in this study. And then moving on from our field study, I would say most interesting data we've collected was from our soil amendment study. So using coffee grounds as a soil amendment, we saw very mixed results when we were looking in the literature. Some say coffee is great, some say coffee is the worst, and some are in between. And it seems to be rate and species specific effect by the coffee grounds on any particular crop. And so we modeled this study after a USGA spec putting green, which consists of a 12-inch sand layer on top of a 4-inch gravel layer. And we replicated this in 6-inch PVC pipes with 12 inches of sand on top of 4 inches of gravel. We then compared these amendments to peat moss, which is currently the industry standard for sand-based root zone amendments. So we amended our pots with 10 and 20% of treatment by volume. And we took that one step further and broke down our coffee grounds into 2 different particle sizes, one being a coarse particle size, which was 1 to 2 millimeter diameter, as well as a fine particle size, which is a 0.25 to 0.5 millimeter diameter. We sodded our columns with Tifway. We let them grow in and develop their root zone for 6 weeks before we started the trial. And then we submerged them to allow them to saturate, drain to field capacity. We threw ammonium sulfate on at a rate of 1 pound per 1,000 square feet and 1 pound nitrogen, And then after this study was done, we looked at a dry down study to see any effects of water retention that these coffee grounds might have. So again, we are going to be looking at turf quality, tissue nitrogen, soil transpirable water, and days to wilt, all at the treatment by rate effect. Okay, so let's dive into this. Again, a 5 is going to be the minimum level of acceptability. And the most important thing that we're seeing here on turf quality is that generally our amended pots are better than the unamended pots, especially at the coarse 10% rate. So what might be happening in like a 20% is that there are still phytotoxic compounds remaining in the coffee grounds that do eventually leach out, at which point you only have positive effects that I've seen so far. Our dry down study. So again, we submerged our pots after this 6-week study was completed, and we allowed them to dry down until we saw signs of wilt, at which point we rescued and rewatered them again. The data collected here was volumetric water content, days to wilt, and water loss. So our days to wilt, the most important thing that we saw here is that basically anything that you amend the sand with allows the turf to survive for a longer period, which seems pretty obvious, but one of the things that we noticed is that coarse grounds definitely compete with peat moss as far as the ability to retain water. So if you're competing with peat moss, it's already a viable alternative, and then we'll go a little bit deeper into that in just a moment. Another interesting thing we did is after the dry down study, we allowed the turf to recover for 2 weeks, at which point we collected clippings and analyzed them for tissue percent nitrogen. As you can see here, both coffee treatments retained more nutrients in the tissue than peat moss or the unamended sand alone. So they outcompeted them as far as nutrient retention goes. It's likely because obviously there's more nitrogen in the leaf tissue than in the coffee amended sands than there is in the peat moss amended sands or the unamended control. So conclusions are that coffee grounds as a fertilizer alone, not so much. It doesn't work great as a source of fertility. But when you combine it with another source of fertility, like you saw in the GeoJava product, it seems to have some ability to either elongate the effects of the fertility or produce some other beneficial trait that we need to look deeper into. So to put it in perspective, this is right before we took our clippings to send in for nitrogen analysis. So this is 2 weeks. 2 weeks after recovery from the dry down, and you can see that all of our coffee treatments, which are this guy, basically the PM is our peat moss treatments, and this is sand. So these are our fine, our coarse, other fine, and other coarse treatments. And what we're seeing is much darker green color, much more dense turf, as well as a lot more growth going on after drought recovery. So future directions, what we need to look into in the future is the spent coffee grounds effect on microbiology. We can't be certain that this is just some sort of nutrient retention because we haven't really analyzed that yet. We are doing an incubation study on the nitrogen release rates of spent coffee grounds. And so hopefully we'll kind of parse out a little bit better what's happening, as well as the chemical composition beyond the macro and micronutrients, seeing what exactly is causing any phytotoxic effects within these coffee grounds. I've read in the literature that caffeine is phytotoxic, but it's also one of the first compounds to break down. So beyond this, what else could be causing any detriment within these coffee grounds? And also cold brew compared to traditional hot brewed coffee. The cold brew is going to leave in a lot more compounds than the hot coffee. And we need to see what exactly is going on, how long it might take for any of these detrimental compounds to leach out of the coffee grounds. Because like you can see here, there's definitely no more phytotoxicity. It hasn't been fertilized in 4 months and you still see rapid growth. So there is more research to be done, But I think that this is definitely a viable candidate for becoming a realistic soil amendment, especially in the quantities that it's being produced in. And with that, I would like to thank my committee, everybody who's helped me out at the lab, and especially our sponsors, the USGA, GeoJava, Tree, and the RC Potts Foundation. So at this time, I'll take any questions if you have any. Yes.
For your visual turf quality, was it just based on experience, the 1 through 9, or is there a standardized way that you were looking at it?
So it is just a subjective visual rating, but we also do take the NDVI and the Lightbox images just to make sure that I'm staying true.
There's a method that NTEP or National Turfgrass has developed, and it's primarily based on color, texture, density, and uniformity. So there's a little method to it, but it's often criticized. In fact, crop science, if that's all you have, they won't accept the feed right now.
Yes.
Your fertilizer treatment actually produced more mass than your ground coffee treatment, even though the quality is lower. How do you explain the difference in that? Because you would assume that if they grow faster, the quality is probably better as well.
So with a higher rate of coffee grounds, you're going to be introducing more possible phytotoxicity, right? So while you may be providing more nitrogen, some of these compounds might not give it that dark green color, causing stress and a little bit of fluorosis maybe within the tissue. So while it may be growing faster, it doesn't mean the quality is higher. Yes.
So the amended part of the experiment was with amended sulfate.
Mm-hmm.
Why did you pick that? Because it wasn't doing the best in your percentage.
So
Why did you like
we wanted to see a leachable nutrient, right? So the reason that we were seeing, partially the reason we were seeing the turf quality not so high on the ammonium sulfate is because it greens up really fast, and then we were collecting clippings, so we're not allowing any of that nitrogen to return. So you've got really high nitrogen in the tissue, and you're not allowing it to return, but also that quick green up kind of dissipates really fast, and it goes back to control levels. Yeah.
What do you think is causing that difference between coarse and fine grain coffee?
So that is really interesting. We've seen in the soil amendment study where the coarse grounds are, okay, so let's see, let's back up a little bit. We saw, when I first got some coffee grounds, I was drying them down to have a fresh stock. The fresh stock, we had 2 55-gallon trash cans full of soaked coffee grounds. And by the time we dried them down for 3 days at 65 Celsius, they shrunk so much that you could only fill 1 trash can up. So they do have the ability to really retain a lot of nutrients, and the coarse likely have more ability to hang on to water and nutrients. We also saw the roots of the turf growing through the coarse grounds, whereas they couldn't do that in the fine grounds.
Thanks.
Yes.
Why do you use, I guess, 2 different Bermuda grass varieties in your different experiments? Celebration and Tipway, right?
Yes.
Why do you choose, I mean, why do you do different?
So it was more of a practical choice. We had a celebration Bermuda plot that's on native soil, and these were going into sand-based root zones. So we have Tipway stand, Will's Tipway. He has it on a sand-capped fairway. So in order to not bring any of our native soil in and really wash those roots off and make sure we have just purely sand-based root zone, that's why we use the Tipway. Yes, sir.
You started off by saying that you didn't expect your research to win the award. Would you like to elaborate on why that would be? Because that was pretty good.
Oh, I appreciate it. I appreciate it. Oh man. Well, I suppose it is a bit intimidating coming in here and people were flashing all kinds of crazy equations on the board and I have no idea what's going on. And I'm coming in here and saying, hey, I put coffee on the grass.
So, I mean, I think you have a good chance of it being noble, right? If you sold it the right way, can you say that caffeine helped the grass grow?
I can't say that now. Yes, ma'am.
So I have a question from Zoom, from Jason Rains, who's interested in what effects do you think that increase in the acidity has on, from the coffee grounds, has on the turf plots in the long term? And, do you think that's going to become an issue?
So I would say, especially in the top dressing fertilizer, that the amount that we are putting on is not going to be able to acidify the soil to a very high degree, if at all. As far as the soil amendment study goes, I don't think the acidity is going to be the major issue compared to some of the other compounds that are in the coffee grounds. That is a question.
First, like calling a station where the water is very saline.
Mhm.
I mean, can that be a positive thing?
It could be, but I think the amount that you would have to amend or top dress with would be so much that you would cause a lot of unintended consequences trying to reach a suitable neutral pH.
So Garrett is taking soil cores from the field plots that they just did and removing that bachelor to get rid of all the coffee grounds that might have built up, but they're doing the full chemical analysis of that soil to see if it's changed acidity and nutrient levels.
So that's underway at the moment, but we'll get those back in a few weeks, hopefully. Yes.
Okay, if your goal wasn't to improve soil quality, but it was to conserve water, do you think you have an award-winning idea for areas that are semi-arid, or if the goal you mentioned about how much water we use per day on turf or just grass in general, would you see promise in areas that this could not be a fertility amendment, but a water saving amendment?
So, excuse me. So, I think I would say that this is probably going to work best in sand-based root zones, right? Because any detrimental stuff that might be in there will be able to be leached out very quickly versus some other soil types. Everything's going to hang around for a little bit longer. But yes, I think if you do have a sand-based root zone or a sandy soil, I think this could be a real viable option for you to retain water, both water and nutrients.
I think so too.
We have another one here.
We have one more question from
Okay.
online. And so this is from Galen Roberts, who is interested in whether or not you'd expect significantly different chemical characteristics on different varieties of coffee beans. So he's wondering if you expect different nutrient contents or toxicity in light versus dark brew.
Oh man, I don't know if I can speculate on that. I'm sure between the different species of coffee, because you have your Arabica, your Robusta, I think there's one more, but those are the two major varieties or species, I believe, of coffee that are grown, and I'm sure you would have a different chemical composition between species, and it depends on if these coffees were flavored, if they, I'm sure roasting has some sort of way of affecting that, but I'm honestly not sure. I don't want to speculate too much. Yes.
Oh, yeah. I was wondering if, like, do you think at a larger scale, like stadiums, I don't know, if, I'm assuming you do like an economic analysis, but do you think they'd actually
Yeah, so I mean, the soil amendment study was for sand-based root zones. So like Kyle Field is a huge sand-based sports field. And it would definitely have to be a renovation type project. You would tear up your whole turf field in order to incorporate this in. But I think that if someone was going to start a project, this would be an alternative amendment compared to sphagnum peat moss that people should really consider using.
With that, we have no more time. Thank you so much.